3, let's go ahead and make that unit 3. So I'm writing our AP Computer Science project, and I'm going to make unit 3. It's a package, unit 3. I'm going to go ahead and make the class inside of unit 3 as well, also called unit 3, but this time it's an uppercase U. Main method needed. Let's create that. And so we're in unit 3. Only in the main method we are working. The first thing I want to do in unit 3 is talk about Boolean logic. So we have the introduction to Boolean logic. What I'm looking at here is the AND statement, the OR, and the NOT. P and Q are Boolean expression. Anything that happens to be true or false. That's what Booleans are. So P and Q are here, and we have some statement over here called the compound statement, joining P and Q with an AND and an OR. Then we have not P, and we also have not Q. So for AND, it's true only when both statements are true. As a matter of fact, it's true when all statements are true for an AND. If there were more than 2, all of them got to be true for it to be true. False every other time. In an OR, only one has to be true for it to be true. The final statement for this OR becomes true if just one of them has to be true. So if we had more than 2 statements, if we only had one statement true, the whole thing's true for an OR. Not is a negation, so it changes true to false and false to true. So if you look at P, not P, F here represents false because over here it's true. And this is false because over here it's true. And the 2 true on the bottom suggest P was false. Same is true over here for not Q. Okay, so this is something that we need to use because sometimes we have Boolean statements that we need to join. And the example of that would be, let's say P represent the correct username and Q represent the correct password. We want to log in with an AND because it's going to be true for you to log in if your username and your password are both correct. Now, if you look down here, we have some equivalence. And these are some laws that you can use in conjunctions to these AND and ORs and not to figure out the easy way of writing this statement. So P and true is P. Whatever P is, that's what the answer is. Like if P is false, this turns out to be false. And if the P is true, this turns out to be true. So whatever P is, what we get there. P or false turns out to be P, right? Because whatever P is, that's the answer. If P is true, it's true. If P is false, it's false. Domination laws using short-circuiting code. Let me talk about short-circuit. See, OR gets short-circuited with true. So if you want to write efficient code, you should put the most likely true statement in front if you're dealing with strictly OR. Okay, because the most likely true is in front. The minute it hits it, it ignores the rest. So let's say we had 10 of these. Let's say we had 10 Boolean expressions and we had them all connected with ORs. If you put the most likely true in front, once it's true, it's going to ignore the rest of the statements. All 9 of them are going to be ignored, and the whole thing comes out to be true. Same is true for false, okay? False, on this case here, I shouldn't say same is true for false, same is true for AND. The AND statement short circuits on the false. So if you're doing AND, you want all the false, most likely false, to be in front. Because the minute it's false and it sees an AND, the whole thing turns out to be false. That's the idea of domination, right? Domination laws. And these laws idempotent, idempotent, I think is what it's called. Simply saying if you make an OR and AND with the same thing, it's just itself. Pretty straightforward there. Now we have the negation laws. If you do a not P, it's P, right? If something is not double negative here. Not P is P. Commutative laws, all right? If you have an OR statement, it doesn't matter the order. Just like we did up in short circuiting, it doesn't really matter the order. So since that's true, try to put the most true statement in front for an OR. And you want to put the most false statement in front because it short circuits on false. Associative laws, if you have more than 2, like in this case 3, it doesn't matter which one you do first. If you do the first two first, the first pair or the last pair, once you do the OR statement, it turns out to be the same. Same is true for AND. Then we have the distributive laws. P, R, Q, and R is the same as, and it's called a distributive because it's almost like you're multiplying. You take the P or Q first, and we do the P or R last. Okay? Then we have the AND also, same. P and Q or P and R right over here. So those are some distributive laws and properties that you could use if you're writing code to simplify things. Like if we had this, we can simply write it as that. And if we had this longer one, we could shorten it a little bit. And the last but not the least, the De Morgan's laws, distributing and factoring out a not. Okay, so if I'm distributing the not, everything gets notted, if you will. Not P, not AND, not Q. Well, not AND is OR. Okay, and not OR is AND. So not P, not OR, not Q turns out to be not P and not Q. The reason why I have the factoring out is because I'm going from right to left. So if I had two knots here, or even if I only had one knot, and I was to factor it out, factoring out of an OR gets me an AND, factoring out of a not Q gets me a Q, factoring it out of a Q gets me a not Q, and so on. So that brings us to the end of the introduction to Boolean logic.